Craig with Authentic Battle Damage. That's right. Today we're going to talk about binary operators. We're going to represent our tic-tac-toe board as a binary field using ints. We're only going to use the first 9 bits, say in a 32 or 64-bit integer. And so to work this out, I'm going to kind of explain what we're going to do. So in C#, we're going to be able to have in the model, we'll have a public int player X equal, and then this is how we can, now we could say 0. So that means all of the bits are off. But we're going to write it like this. This is going to allow us to write out the binary pattern. And then we can use these underscores, which they're ignored, but they're just for readability. So that'll be the top of our tic-tac-toe board. This will be the middle. This will be the bottom. And then public int player O is going to start out with the same. So the way this is going to work is our board will no longer be represented as the dictionary. We're still going to use the dictionary, but this is going to be really cool the way we're going to use it, in my opinion. So one player, so say player X. Let me make this bigger. Player X is going to have, let's say they chose C3. Player O, let's say they chose A1. So what we'll be able to do is the board is going to be us anding both player X and player O. And we'll do that by doing, int board equals player X. I'm sorry, we're not going to use and. We actually would use or. Player O. Because what anding does is when you do an and, if 1 and 0 equals 0, let's do it like this. 1, 0 and 1 equals 0. 1 and 1 equals 1. And of course 0 and 0 equals 0. Now what we would do is an or, which is dignified by the pipe. And this is the single and. So oring 0 or 0 equals 1. 0 or 1 equals 1. 1 or 1 equals 1. And 0 and 0 equals 0. So there's another one called the exclusive exclusive or, and it's represented by the caret, and all of these would be true except this one. This would be false. So it can either be one or the other. And that's actually a better approach for us to use, because we do not want player X or player O choosing a spot that has already been chosen. So we can use the exclusive OR, and then we can check to see whether or not their choice has been set. I don't know if that's a good way to go about it or not. But, so yeah, so this is going to be how we're going to approach this topic. And I wanted to, show you a little bit about bit shifting. I'm going to go into Python. This is the repel in Python, where I can do so if I just type 1, it'll say, yeah, that's 1. If I do 1 shift 0, it'll give you 1. If I do 1 shift, and this is shift to the left, 1, it'll give you 2. So what's happening here is the first one was all zeros, and then we did the 1 shift 0, and then it made it 1. And then when we did the 1 shift 1, it made it like this. And because, as you know, in binary, so this is 1, 2, 4, 8, 16, 32, 128, 256. So for example, if we wanted to print out 3, we would do 1, 1, because 1 plus 2 is 3. So if we were to add 1 to this and make it 4, because this bit represents 4, this one would be on and these would be off. And then 5 would be this. So it would be 4 plus 1 be 5. And then 6 would be this. So 4 plus 2 plus 0, or not 1, would be 6. So we got here 3, 4, 5, and then 6. So that's how binary numbers represent real numbers. And we're going to be able to use the positions of the bits that are on and off to represent which square each of the players have. And then what we'll be able to do is we'll be able to specify all of the win conditions. So this will be 1 win condition, and then this will be another win condition, and so on. We'll be able to specify all the win conditions in binary, and then all we have to do is then just and them with, say, player X. And if it equals the win condition, because all the 1s and the 1s are going to be preserved. So if player X has it, and when we AND it and it equals the win condition, then we know that they have it. So this will be a really, really quick way of checking. And again, there's really no reason to do this except for the fact that you're learning how to work with binary numbers and how to do bit shifting, or anding and oring. It's basically another name for this is flags. We can use these as flags. So what we're doing is we're saying that the tic-tac-toe board, each position, each square on the board is a flag. And then here we're going to be able to use this to store our data. And then also do the comparisons, which is going to dramatically change the way this looks. We won't have this anymore. And we won't need to do this link. So in the next one, we're going to start making these changes, and it will be good. Bye.